Well, it turned out on the original board, we ended up nicknaming some of the sections, like the 04 BGAs, we'd call it tic-tac-toe and these type of things. So from the outset here, I decided to name the sections. For example, this here we call Tombstone Alley. This is another thing that's a DFM-related item that just does not get communicated to designers. These are capacitors, and capacitors love to tombstone. And it's because of thermal differentials across the device. So what we typically see is a metal-defined pad on one side of the cap and a mask-defined pad on the other. Let me see if I can bring the mask up a layer.
So just for everyone that's listening, what we have here are some big copper pore regions, and then we have some SMD components lined up around the edge of these copper pore regions. And I see here we have some of those SMDs have a thermal attach and some of them don't. And I guess this is kind of a side-by-side comparison of the number of defects you would expect to see.
Exactly. Again, that gives us the quality metrics to have the conversation with the designers and the owners of the product. Do you want to risk the defects, or can you put the thermal relief in?
Now, here's one thing I've been dying to ask somebody about just exactly what you're showing here with tombstoning. If you go online and you start reading about, DFA, you start reading about DFM, you start reading about assembly defects, it's almost obligatory that somebody says tombstoning. And it's, they talk about it as if it's like the most common thing, and you need thermals everywhere. And no matter what you do, if you don't have a thermal, you're going to see tombstoning. How common is it really? Because I feel like it's talked about as if it's more common than it actually is.
I think you're right, because when we do tombstoning tests, to get good sample sizes, we literally do hundreds of thousands of joints. Again, tombstoning is due in large part to this type of scenario where you've got an unequal thermal, and they will exactly tombstone, or so we're hoping. Another thing that we've also been finding lately is if you control the tombstone, you can end up with a nice solder joint on your metal-defined side and a cold joint on your mask-defined side.
I see.
So even though it's not a tombstone, it's still requiring rework. Every time we rework a board, we reduce its reliability.
Right. That makes sense.
We try to avoid that at all costs. We built these tombstone alleys for our 0201 caps, our 0105 caps, and our 0804 caps. Caps are a lot more likely to tombstone than resistors because they have 5-sided terminations. And the mechanism by which tombstoning occurs is the melted solder wets to one end, and the surface tension just pulls it right up. So whichever side melts first is the base of the tombstone.
Yeah.
Resistors don't tombstone as much because they only have 3 sides of metallization. So there's not enough metallization not as much metallization for the solder paste to grab. But now we've got this new phenomena that we just designed in down here, and we set it up similar to the Tombstone Alley. I've talked to 3 different assemblers in the last month who are dealing with bottom-terminated Zener diodes. These are 0201 or 08 or 01005 packages, and they have very small bottom terminations, and they're very light. So what happens is, again, the side that melts first, the solder pulls it. It doesn't pull it up because it's bottom terminated. It pulls it laterally, and you will see all of these skew by the same degree in the same direction when they have the uneven thermals.
Interesting. But they would all do the same thing.
Yes. And we've done things where, we'll switch orientation in the machine, or we'll switch orientation in the reflow oven, or we'll run it at 90 instead of 0, and they all still skew in the same direction. So I'm convinced it's due to thermal differentials, and that's why I put these on this revision of the board.